Okay, so this is 7b, which is composite and inverse functions. We've actually done composite functions and inverse functions already, but when we did it, we hadn't really done anything with circular functions. We maybe looked a little bit at this kind of thing as well, except we need to be able to apply composite functions to these types as well. So we are going to practice a little bit more here. What you'll see up the top of your notebook, this is just copied from previous chapters that we've gone over. Okay, so this isn't anything new, it's just a little bit of a reminder. Now, this first example, it's slightly new. It's saying, as you can see, for the following, express as the composition of two functions. So what it's saying is we can show that this is actually made from two functions. So this is one function here, isn't it? Like the whole thing put together. But if you look in this section here, you've also got a 3x squared. That's sort of a function on its own as well. Same with this one over here. You've got the function like of the whole thing, but then this part in the power, that's sort of a function as well, isn't it? So instead of just saying h of x equals this or h of x equals that, we're going to kind of split this up into two different functions. Okay, so let's just say that f of x is our 3x squared for this one. There we go. But we've also got this 2 cos as well, don't we? So let's just say that's g of x. 2 cos x. Alright, so we've got these two rules here, and h of x is actually just the rule of g of x, but you've substituted f of x in there. So it's going to be g of f of x. Now, if you try to work out what g of f of x is, so put this inside there, it's going to give you that. Okay, so that's what it means by that. There's actually a couple of different ways you can do it. Like you could just say that the number 2 is a function as well. There's not just one right answer. All right, now let's look at this one. So what I think we should do is maybe look at this section here. Let's just say this is a function, so we'll call that f of x. So f of x is 4x plus 1 all squared. And we also have this e function as well. So let's just say that's g. And g of x would just be e to the power of x. So if we're expressing h of x as the composition of two functions, h of x has to be g, function g, but then you're putting f of x inside it. And again, if you work that out, you should end up getting this here. All right, let's move on to the next one. Okay, so now we actually are finding some rules. So this is stuff that we've done before, except as I said before, we're using these different types of rules. So logs here and circular functions here. Now it says to find f of g and g of f. So hopefully we remember that this can actually be written as f of g of x. They're the same thing, those two. And this one here is just g of f of x. Exactly the same thing, just a different way to write it. So let's make sure we're not getting confused by that kind of thing. I prefer to write it like this, but you can do whatever you like because it's both right. Now for this question it says we're finding f of g and g of f for both of them, which means we're kind of doing 4 questions here. I'm not going to do all 4 because I want this video to be reasonably quick. I'm going to do g of f for this one, where that's our g and that's our f. And I'm going to do f of g for this one. So that's our g and that's our f. Except I've been a little bit stingy when I've made these notes. There's not a lot of room here. So I'm going to actually do this on another piece of paper. Alright, so here's a, there's our g, there's our f, and for this one we're going to find g of f of x. So what I need to do is substitute this into my x there. And that's all squared. Now you might look at this and be like, how the hell am I going to be able to find the domain and range? I don't even know what this looks like. Now you don't really need to know what these look like to be able to find their domain and range. So I'll show you that with this one and the next one as well. So don't stress too much about that. All right, now let's think back to when we were doing composite functions. We need to firstly have a look at the function that's on the inside. So f is on the inside, so we're looking here. Now, what are the values that can actually go into f? So what's the domain of f? Now, the domain of f is just negative infinity to infinity, or r, isn't it? So every value can go into f, but we want to see the values that are going to come out. So this function here, the values that are going to come out of the y value, so we want to know what the range is. Now, because you've got an amplitude of 3 and your average is 0, it would say plus 0 over here. That means you're only ever going to get out values from negative 3 all the way up to 3. Cool, so we've worked out f of x, but now you move over to the outside. So we need to see what values can actually go into g of x. All right, now g of x is here. We know that the domain of this parabola here is going to be from negative infinity to infinity. Except the problem is that f is only going to output these values here. Okay, so g can take all these values, but it's never going to get all of them. It's only going to receive values like that. Okay, so we actually need to change this domain because it's only going to get these ones. Cool. Now the domain of g, it would be from 0 to infinity, except how are we going to get from 0 to infinity when we can't take all these values in? Well, we can, but we're not going to actually get them. These are the only ones that we're actually going to get. So we need to know the y values that come out of this little g machine here that correspond to these x values. So I'm going to schedule a graph of g down here. So it's just this real simple parabola, most simple one, isn't it? So just like that, this is our g of x. Now g of x is only ever going to get its x values between negative 3 and 3. So let's just say negative 3 is here. Let's say 3 is here. So you can include those numbers as well. But it never gets anything other than that. So we're not actually going to get this part. Okay, it doesn't get those x values, so it can't put y values out there. Alright, now what we need to know is the range of what's happening here. So these are the x values that can go in. What are the y values that can come out? So we can see that it starts at 0, a y value is 0, but we want to know how high up it goes. So this bit here, 3 squared will be 9, negative 3 squared is also 9. So we can see that the range is actually from 0 all the way up to 9. It includes 0 and it includes 9. Alright, so we don't need that and we don't need that. This is our range of the whole function, this bit here. This is range of, what have we got here? G of f of x. And over on the other side, this is going to be the domain. So the domain hasn't actually changed at all from the start. G of f of x. Sweet, and we're finished. So that's our range, and that's our domain here. Let's move on to the next one. Okay, so this time we've got these two different rules. Well, g is still the same, but we've got a different f, and we want to know what f of g of x is. We've been asked for the rule, and we'll give the domain and range afterwards. So let's put g into f. There we go, so there's our rule. Now again, you don't even need to know what this looks like. The squared might change things a little bit, but you don't need to know what it looks like at all to work out what the domain and range are. Alright, so let's set the same thing up as we did up here. Let's have a look at the values that go into the inside section and then work from there. So inside we have g of x, so that's where we're going to start. Alright, we want to know the x values that can go into g of x. Alright, so the x values that go into g of x can be negative infinity to infinity. And the y values that come out of g of x, that's going to be from 0 to infinity. Alright, now let's look at the outside f of x. Alright, so what are the possible values that can go into f of x? Now, f of x is here. Now hopefully you remember, but this should look something like this. It's a log graph and it's been moved 1 unit to the right, so we should have an asymptote here at 1, and it should look something like that. Okay, so our domain is going to be, because it can't touch that asymptote, it's going to be from 1, not including 1, all the way to infinity. Now I'm just going to put the range in for now as well. So the range of this one is going to be from negative infinity to infinity. Okay, let's start evaluating what's going on here. So these are the values that can come out of G. These are the ones that F can compute. So if G pushes out a value of 0, we can't actually put that into F because it doesn't exist within this domain. So we actually have to restrict this range to make it work. Okay, because currently this isn't defined. So let's make it so everything that comes out of here can also fit into here. So we're going to have to change this range to that domain. Alright. Now, if G's only pushing out these ones, that means F can deal with them all, can't it? So we're all good there. So that means that this is actually going to be our range, because we didn't have to change that. So that's the range of, what is it, f of g of x. Alright, but we had to change the range of g over here, didn't we? Now if we restrict the range of g, that means it's also going to cause a restriction on the domain of g. Alright, so I'm going to set up a little graph again just to show you what's actually happening. Alright, so we're talking about the rule G, which is this parabola. So there's our parabola again. Now the range was from 0 to infinity, except that didn't work, did it? So we changed it to 1 to infinity. So the new range is going to be from 1, which can be about here, all the way up. So can't include it, so that's why we put those open circles. So we want this section because it's within that kind of range, and we want this section because it's within that range. This bit here, we don't need that at all, do we? Okay, so this is the bit that's outside of our range. So that's gone. We can just like delete that. We need to say what the domain is for this range. Okay, so I can see that this arrow keeps on going forever, and it stops here at a certain x value. I want to know what these x values are. So let's find the x values where y equals 1. So we've got y equals x squared. We will know where y equals 1. So x is going to be plus and minus 1. So that's minus 1, that's plus 1. So we can see now that our domain is going to be this bit and this bit as well. So that would mean that we have from negative infinity to -1. That's that section. But we also have from 1 to infinity. So that is the domain of our composite function. Okay, done. Now I should cross that one out because that's an old one that doesn't apply anymore. So this is saying after these restrictions, these are the values that can go into G. These are the values that come out of G. And then we go into F. So these ones can fit into F. All good. And now if you put those ones into F, these are the Y values that it's going to push out. Okay, so we're finished with those ones. Hopefully that was a little bit of revision because that's something that we did do in composite functions, which I think is 1E. If you're still struggling with this a little bit, that's fine. It is, or it can be a little bit hard. So go have a look at 1E, or maybe ask me a few questions. Let's move on to the next section, which is these two questions here. Again, I'm going to do them on another sheet because I've been stingy again and haven't given you much room. I want to make sure we've got plenty of room so we're not getting confused. So this might look a little bit funny because we have inverses, but also as a composite. If I was going to write this in another way, I could say that we're going to have the inverse of f, but then substitute g of x into it. These two mean the exact same thing. Right, now the first step that I'm going to take is I want to actually work out what the inverse of f is. We have f here, but I want to know what the inverse is. So I'm going to take f, swap those x and y values, and then solve for y. And that's going to be my inverse rule. There we go, so I've swapped them. Now I just want to solve for y. There we go, now I'll solve for y. One thing though, see how there's a half here? I suppose we could leave it like this, but with the rule how you can move anything at the front of your log to the power over here, I'm going to do that. So I'm going to move that half over there, so it's going to be x to the power of 1/2. Remember, to the power of 1/2 is square root. So we can say that our inverse of f is log e root x. There we go. So we've got our inverse. We just need to substitute g into it now. So our g is up the top here. I want to put that into our inverse rule instead of x. Oops. Okay, now instead of x, I'm putting this here. Now that looks yucky, doesn't it? You've got your 4 times square root of x under a square root sign. Let's actually think about what's going on here. So, as we said before, your square root sign is the same as anything to the power of 1/2. So we've got, I'm just going to change that to a 2 because the square root of 4 is 2. So 2. And then we have, actually no, I won't do that. I'll just separate the whole thing. You've got the square root of 4 times the square root of the square root of x. Now we know that the square root of 4 is 2. So we can put our 2 there. This looks a bit more complicated. So we have times, and then square root means to the power of 1/2. Square root means to the power of a half there as well. So now hopefully we can use our index laws and see what this ends up coming out as. So remember, with your index laws, you're timesing this by that. So we're going to end up having 2 times x to the power of 1/4. Now, x to the power of 1/4, we can change that into root form as well, except it's not going to be a square root, it's going to be a 4 root, or however you say it, I'm not even sure. There we go. So we're now finished. That is the rule for the inverse of f of g of x. Sweet, done. Let's move to b. Okay, now this looks slightly different. You see how over here it's just f that's got the inverse? Over here we have the whole thing inverse. So it wants us to find g of f of x and then find the inverse of that. Alright, so let's just forget about the inverse for now. Let's find g of f of x. Alright, here's our g, here's our f. So we're going to put our f into g. Okay, there we go. So we've substituted that one in, and that's the rule. We don't really need to do anything apart from that, I don't think. I mean, you could make that to the power of 1/2, and then it would just be 4 times e to the power of x. That might actually be easier. Let's do that. There we go. Yeah, that looks easier. All right, now we want to find the inverse of that. So g of f of x, but the inverse of it. So what we need to do, remember, is swap that x and y. So it's going to be x equals 4e to the power of y, and we just need to rearrange here. Actually, no. I can't rearrange to log just yet. I need to make sure that 4's moved away. So I'm going to have x on 4 equals e to the power of y. I'm solving for y, so I can change to a log. Y equals log e x on 4. And that is it. But when I show my answer, I need to make sure I'm using proper notation. So I'm not just going to leave it like that, because that doesn't say it's the inverse of anything. So let's use that proper notation. Remember, it was g of f of x, but the inverse of that. And we're finished. Now we just have one exam question this time, so let's go over what it actually means. So which one of the following functions satisfies this equation here for every real number x? Now this is our composite function. It looks a little bit different though, because it's f of x. Normally we have g of f of x, or the other way around, but that's okay. We're just using the same rule. So we're substituting f of x into x on that original rule, which is called f. Now once we do that, the answer should be x. We need to work out which of these rules that actually works for. Alright, now this is another one that's slightly annoying. I'm going to use trial and error again and just hope it's not e. But let's just see how we go. Alright, so we want to substitute f of x into f of x. Okay, so instead of x, I'm going to put 2x for this one. That ends up giving me 4x, which is not x, so that's no good for me. I don't want a. The next one, we're substituting x squared into x. And that's going to give us x to the power of 4, which is not x, so that's not what we want. Alright, we're up to c. We're substituting 2 times root x into x. There we go. That looks a bit strange because you've got a square root and a square root. It'll end up being this. Which is not x, so we don't want c either. Now d, we're substituting x minus 2. So x minus 2 minus 2, that gives us x minus 4, which is not x. So it's not d, that means it has to be e. Let's just make sure that it is a though. So we're substituting 2 minus x into x. Okay, so 2 minus 2 plus x is x, which is exactly what we wanted based off this bit here, so the answer has to be E.